and I have got the pleasure to open to a lecture entitled Wood Pellets, the Future of the Energy Market, organized with the framework of the Transform for Europe project. We are pleased to welcome Dr. Engineer Agnieszka Drobniak from Faculty of Natural Sciences, University in Silesia in Katowice, and we are pleased to welcome Mr. Lyubomir Kostov from Veolia Energy Varna from Bulgaria. Maybe it's time to ask yourself a question. Is wood pellets the fuel on the future? Is it only a transition fuel in the area of decarbonization? Will we stay with use forever? I don't know. We will find out the answer to these questions in a moment, because Agnieszka will talk about the history of using wood pellets as a source of energy concerns regarding fuel pellet quality and the pros and cons on using biomass for energy purposes. Agnieszka, let's start.
All right, thank you for having me. Good evening, everyone. And I'm going to start with a few words about myself. I have a master and PhD degree from the Academy of Mining and Metallurgy in Kraków. And while I did my PhD, I received a scholarship from a Battery Foundation, and I spent 6 months at the Indiana University in Bloomington in the United States working on my doctorate. Shortly afterwards, I defended my thesis and I got a job offer from the American University. I took it and I spent over 20 years working at the university in US, working on a very collaborative projects with scientists from all over the world, related mostly to energy resources and critical elements. In the last 4 years, I've been very interested in biomass energy. With my colleagues from the University of Silesia, I co-founded Center for Biomass Energy Research and Education. And very recently, I became a beneficiary of a very prestigious program of the Polish National Agency for Academic Exchange. The program is called Polish Returns, during which the agency tries to bring back Polish scientists who worked and resided for many years abroad. So they would come back to Poland and bring their knowledge and know-how. And over the next 4 years, I will be working on biomass-related projects here at the University of Silesia in Katowice. So before I get to the main topic, I want to spend a few moments to talk about current stage of the energy. And this is very well shown by this graph that goes back 220 years. If you look at the beginning of the 19th century, you can see how little of energy comparing to the amount of right now we human used. And how not diverse the sources were. It was pretty much the traditional biomass, and how diverse the sources are right now. What's really staggering is that many of the reports say that most probably in the next 30 years, so by 2050, the amount of energy we consume will double. So of course the question is, where is it gonna come from? So if we look at what's happening now and in the last 20 or so years, you can see that the primary energy is still coming from the fossil fuels. So we have oil, then coal, and then natural gas. And while the renewable resources are slowly growing, their usage is growing, they still account for roughly 6 to 7% globally. And when it comes to energy from biomass on a global scale, it's roughly only about 2%. And only in some countries like the United States, that percentage is much higher and accounts for roughly 5%. But of course, these were the data on a global scale. When we look on a regional scale or a country scale, that situation is slightly different. And this graph shows where our electricity is coming from. And I marked Poland and I marked Bulgaria for obvious reasons. And it's easy to see. Poland is very heavily invested in fossil fuels, while Bulgaria has quite significant source of electricity coming from nuclear energy. Other countries like Denmark or Austria or Sweden very heavily already use the renewable resources. So what's going to happen in the future? We have many reports, many models trying to predict where is the energy going to come from. Here, a graph from one of them. It's a report released by the US Energy Information Administration just a few months ago that looks at the next 30 years into the future. And what's interesting, petroleum and liquid biofuels dominate the market. We see a drastic increase in the renewable usage. But please notice, natural gas and especially coal. The level, especially for the coal, not so different when it comes to the amount of the usage from what's happening right now. Of course, this is a prediction. We don't really know what's going to happen. So let's move on to renewable energy. Of course, we have 5 major types: solar, wind, hydro, geothermal, and bioenergy. And bioenergy is a very broad umbrella for simply energy made from plants and animals. We think that this is a new concept. The truth is that renewable energy has been with us forever, right? Because we used wind to power our boats, to sail. We used wind or water to grind the grains. So really, that's not a new type of energy that we as humans use. The bioenergy simply is divided into solid, liquid, and gas energy. And one of the types of the solid energy are the pellet fuels. So what are they? Currently, they are the most economical way of converting biomass into fuel. And I will some graphs show in the next slides. They are a very fast growing component of the energy sector. Pellet fuels can be made from a variety of types of biomass, but the goal here is to use the waste. And we have a lot of waste. We have industrial waste, we have food waste, we have various wood byproducts, but we also can grow and use agricultural crops and energy crops. So among the pellet fuels, wood pellets are probably the most common type of the pellet, or at least the one that we probably know the most about. And they are made typically from compacted sawdust and related industrial waste that comes from milling of lumber, making furniture, or construction materials. And of course, wood pellets can be used for electricity production. We can use them for heating, both residential and industrial, and what's very popular in the United States, for grilling. So the history of wood pellets started in the 70s because of oil crisis. And that was the main reason why many countries started to look at alternatives to fossil fuels. And wood pellet making technology actually came from adaptation of animal feed pellet machines. Europe, and particularly Sweden, were leading development of the industry. But unfortunately, when the oil recovery prices went down, wood pellets were not so attractive and interesting anymore. And it took about 20 years, and we've seen again a rejuvenation when it comes to their usage. Why? Well, this time because of rising environmental concerns. And many countries, especially countries within the European Union, started to think about wood pellets again as alternative to fossil fuels. Right now, wood pellets are considered premium renewable energy, and their production and consumption is continuously growing, which you can see that on this graph. Year after year, the production of wood pellets has been increasing. As of 2021, roughly 41 million tons of pellets has been produced. About half of them comes from the production in the European Union, 1/3 or so from North America, and then we see production in Asia, very small production in South America, Oceania, and Africa. What's interesting, this report comes from Brussels every year, does not report production in China. And China most likely is one of the biggest, or maybe even the biggest wood pellet producer. However, we do not have a data that support that. So many reports do not include these data in their reports. So is the 41 million tons of global wood pellet production a lot? Well, yes and no, because just for comparison, I included production of coal. And you can see that Poland itself mined more brown coal than the wood pellet production on a global scale. And just for comparison, you can see how much coal came from China in the same year, almost 4 billion tons. Who are the biggest pellet producers? China, maybe, but definitely US, followed by Canada, Germany, Vietnam, Latvia, Sweden, France, Poland, Austria, and Estonia. US clearly dominates the production market, but what is interesting is how much growth some of the countries did in the last year. And please notice, Poland is among the three that actually show the highest growth in the production. When it comes to consumption, roughly 47 million tons was consumed in 2021, 16% more than in 2020. 3/4 of the wood pellets was consumed in Europe, very little in North America. You might see that discrepancy, right? The biggest producer, yet roughly about 1 million homes in the United States hits their residential homes with the pellet. Why? Because Americans send them to Europe. The country that consumes the highest amount of wood pellets is the United Kingdom, uses them for generation of the power. UK is followed by South Korea, Denmark, Italy, Netherlands, Japan, and so on. But you can see that the various countries use the wood pellets for a variety of reasons. UK, Japan, Netherlands use them mostly for generation of power, while countries like Italy, Germany, or US mostly for residential heating. So we have a lot of pellets on the market. They come from different producers. A variety of the materials are used to make them. So question has popped up about their quality. And of course, the question also is, why should we care? Should we at all care what's inside? And the answer is yes. Well, first of all, and that's part of the research that our team has been conducted, we know that the various properties of wood pellets influence the emissions of utilization. And therefore, once we have the emissions, they impact human health and our environment. So we definitely want to know what's in those pellets, right? And what kind of emissions we can expect. So it's important that we check their quality, that we certify them, that we examine them before they hit the market, because most likely we can find a way to eliminate some of the impurities that are simply avoidable. The quality is also important for the user, the pellet user. It's critical that the stove and boiler users use the right and high quality fuel, especially for the domestic purposes. Because the low quality of fuels not only lead to loss of the efficiency of the stove or a boiler, but they can damage the boiler and of course complicate the maintenance. Because that's the thing with the small boilers. They are definitely less when it comes to the tolerance of the quality of the fuel comparing to big boilers that have large capacities.
Next.
And as I mentioned, that's something that our team has been working for quite a while. My colleagues back in 2016 started to look at impurities in various solid biomass pellets.
Maybe, I don't know. But is here about the connection? It's about this connection here, I think. Oh, this is another thing. Start sharing again.
Almost.
Yes.
So as I said, my colleagues from the University of Silesia, Ivona and Zbyszek, has been working on the quality of biomass pellets for quite a while. And if the picture improves, you can see that they found wood pellets that even with the naked eye, you could see a lot of impurities within them. So a natural question was, well, if there is so much we can see, what is still there that we do not see? So where do the impurities in wood pellets come from? Well, some of them come from the structure of wood itself, the way the wood is harvested and transported, right? Like we can drag the log in a mud. Obviously, it's going to get a lot of impurities in it. Then during the production, we can have input of metals, rust, oil, various grease from a machinery. And while these impurities realistically cannot be avoided it's important that we look at the malfunction of the machinery and eliminate if such occurrences take place. Another source of those impurities is an inadequate source of the material. So if old furniture or construction materials are used, then we might have wood that's contaminated with glues, resin, or paint. Oh, we need your help again.
It's working here, but I'm not sure why. Let's try again.
Perfect. In some instances, the pellets can be contaminated because there is no attention paid to it. My colleagues found pieces of plastic bags embedded in the pellets. Unfortunately, in some cases, those contaminations can also be added intentionally. So shredded plastic or tire rubber can be added to make the ignition easier and increase the heat output. And those examples show how critical it is that we test those fuels, because especially some of them, the plastic, the tire, they can produce through smoke contaminants and toxic substances that actually are cancerogenic. So do we have people checking on the quality? Do we have standards? Do we have certifications? Yes, we do. We have the DIN Plus and N Plus that are popular in Europe. The Pellet Fuel Institute in North America has also its own certification scheme. They are based on variety of physical and chemical properties, and then depending on the results, they divide the pellets into classes. However, it's not that simple because not all the wood pellets are tested. Some are tested occasionally and sometimes for the entire range of product. And unless the lab knows that it needs to look for a specific contamination, they very often miss it. And that's the case with petroleum products. So what our team has been doing, we have implemented reflected light microscopy. It's actually not a new technique. It's a technique that's been used for mostly fossil fuels. But its use when it comes to biomass has been incredibly limited. So over the last few years, our team tested over 700 samples of wood pellets that came from 9 countries. And the results show that while some pellets are very clean and of very high standards, many, and way too many, are contaminated to various degree, and in some extreme cases, the amount of purities reaches 26.7% by volume. If you want to know a bit more of our research here, moment of self-promotion, my colleagues and I founded a center back in the spring here at the University of Silesia. Please check out our website and learn about our research, our projects. And here are some of our collaborators that currently help us with a variety of projects. Back to wood pellets and some of the controversies. Because while many people think about wood pellets as a renewable energy and a tool to combat climate change, we also hear voices that wood pellets threaten climate, that they are really not a green fuel that are not really carbon neutral, that we cut the forest and burn it instead of protect it, that pellet industry threatens public health and creates more pollution. So let's look at some advantages and disadvantages of using biomass. Great advantage is the fact that biomass is widely available. We as society grow biomass, we produce a lot of waste, garbage, wood byproduct. So theoretically, we have almost infinite resource to use. Biomass is also very versatile. We not only can create the solid pellets, but we can also convert biomass into gas or liquid and then use it in a variety of ways, from heating, cooking, to power generation and transportation. When we look at the electricity cost, biomass actually is about at the same level as coal, but when we look at the amount of carbon dioxide emissions per kilowatt hour, you can see quite significant difference between biomass and then fossil fuels. Not yet.
Please open the
Not
picture.
yet.
Software application.
What's exciting about biomass production is the fact that it can be grown and energy can be generated locally. And this way, for some groups, the fact that we can take the power game out of the hands of big companies, it's very exciting. We also have a waste, of course, from using the fuels. However, biomass ash is full of phosphates, so we can yet again reuse it, this time as a fertilizer. There is a hope that the growing bioenergy industry will create a lot of new jobs and stimulate the economy. And that also would be a way to find jobs for displaced fossil fuel workers. However, many studies have pointed out that biomass combustion smoke contains hundreds or maybe even thousands of health-damaging pollutants, including some that are of a cancerogenic nature. Biomass burning, processing, transportation are all source of greenhouse gases that we so dramatically wanna lower. And these processes, especially production and transportation, still need a lot of fossil fuels. There is also a social impact of the industry. There is a great report about the situation in the southeastern United States, where the pellet mills pop up almost like mushrooms after the rain. And while some people welcome the plants, welcome the jobs, welcome the economic opportunities for the region, others are concerned about the pollution and destruction of the forest. Another disadvantage of biomass is that actually is not as efficient as fossil fuels when it comes to the amount of energy produced from a unit. Of course, starting a mill, the industry requires quite a significant investment, and it's not cheap to just start creating the product. A big concern is related to the source of biomass. The idea is that we are, of course, using the byproduct, the waste that we don't need. However, we do know that there are many companies around the world that cut the forest to create the wood pellets. And therefore, if the resource is not properly managed, it could lead to deforestation. And we all probably can imagine that to grow a tree, it's not a season. It takes several years for the tree to be big enough to be cut down to produce the energy. Biomass energy, it's not wood. It's also a variety of energy crops. And of course, they require a lot of space. So if we want to invest in the industry and have more energy coming from the source, what does it mean for us? Would those crops compete with the food crops, with the living spaces? Some types of biomass, of course, is commonly present in the warmer months. And like many energy crops, we cannot get them in cold seasons. So that's an obstacle that producers need to figure out in their supply chain. And of course, water. Growing trees, growing energy crops requires a lot of water. In many countries around the world, shortage of water is a big issue. So using it for watering plants is a big controversy, as we are taking away the water from growing food crops, from drinking water. And of course, big topic, carbon neutrality of the biomass. While wood pellets are classified as renewable energy, some people argue that this is not a climate-friendly fuel. And ultimately, if we don't grow more biomass than we use, then it's hard to think about biomass energy as renewable energy source. So let's talk about the future of the wood pellets. I think many people think, including myself, that biomass will be with us for not just the next few years, but the next generation. The question is, how are we going to use it? Nobody really knows that, especially when it comes to 20, 30, 50 years from now. What kind of technologies we will have to utilize it? Are we going to combust it, or maybe we will switch to gasification, or maybe we will have completely new technology of the utilization? Reports say that, as we can see, the consumption and the production growing in the last several years, this trend is more likely to continue. And the main reason is, of course, growing adoption of renewable energy sources. The reports say that globally we still have quite a significant room for expansion of sustainable wood pellets, provided that some barriers are overcome. And the most important one, the most difficult one to deal with is the investments, logistics, and policies. That growth of the market actually might be quite substantial in the next 10 years. This report predicts that while the market value was roughly around 9 billion this year, it's probably gonna triple within just the next 10 years. And my last slide. So what are the biggest challenges facing the wood pellet market? Well, still not many consumers know a lot about wood pellets or energy coming from biomass. There are definitely investment and operational challenges, raw material supply challenge, especially we saw these problems in the last year or so. We definitely have challenges related to compliance, policies and various regulations that need to be overcome. Wood pellet market also faces competition from other sources of renewable energy, namely solar energy, wind energy, and geothermal. Big unknown, as I mentioned, is the type of utilization technology we will have. Who knows what the direction will be a few years from now. And finally, definitely presence of poor quality wood pellets on the market negatively affects the perception we have. So it's in our interest not to destroy this incredible source of energy. So the last slide is actually a question for you. Do you, based on what you've heard, think that wood pellets are the future of energy market? Are they going to be with us just for a bit as we transition to other forms of energy, or that's most likely energy that might be with us for a very, very long time?
It's
Sure.
sure. No. Okay, thank you very much, Agnieszka. Let's came turn now to Lyubomir's presentation. Lyubomir will show his perspective and discuss future biomass use in Bulgaria. He will answer the question of how attitudes towards the biomass market in Bulgaria are changing in terms of power plants and individual households, and whether cooperation with science in this area is a good direction. Start. Are you ready?
Yes, thank you very much. Hello, my name is Lyubomir Kostov. A few words about me. The past 10 years, I used to work for a big French company, Veolia Energy. In Bulgaria, I was commercial director of the district heating power plant of the city of Varna. And so we made a lot of investigation about switching of fuel, because now the power plant it's using gas as a fuel. In the past it was petroleum products, now it's a gas, but there were a couple of projects who tried to fuel switch the power plant to biomass. So I was part of some of the project, leading another of them. We make a big investigation about the Hungarian market, because it's very developed in the biomass way of doing this business. And now I will present you, first I will start with some basics about biomass, the practical and the industrial view of this business, and then I will give you the picture of Bulgaria with some problems that I hope that you never face here, and then we can discuss something if you have questions. So let's see if this will work. What will work like this. So the biomass energy in general, I want to put some foundation in the beginning. So the biggest difference about the biomass is that we are searching a possibility to circulate the CO above the ground and not to excavate from the fossil fuels, because as you know, the fossil fuels, they store a lot of energy and from the biomass again, thousands of years ago, they're stored underground, and now we are excavating, releasing in the atmosphere, which, as everybody knows, CO2, it's a greenhouse gas, and it's giving us climate change, like a problem. Sorry about the technique, but as understood, it's an old version of this device, and we'll fight with it during the lecture. Okay. So that's why we are forced to search possibilities to use the biomass, because the biomass is the more sustainable way to circulate the CO2 which is already in the atmosphere between the plants and our industry, and to not release additional CO2 which is generating the problem, and not only the greenhouse problem, like a greenhouse gas, but the problem with our health, because less oxygen and more CO2 in the atmosphere means health issues and less activity of our bodies. Sorry about that again. Do you have it? No? Very strange.
Zostaw, maybe.
Okay. So, yes, even now I have a slider, but not. Let's try like this, because there is a moving parts of the presentation. So I will go a bit deeper in the cycle in a minute. So everything is starting from the sun, except the nuclear energy. All of the other energies that we are using in our industries are coming mainly from the sun. The fossil fuels are collected sunlight underground. The biomass is stored sunlight again. The plants are stored in their bodies. That I will go a little bit in deeper to give you a very simple explanation of how the process is working. So the GOAT process is photosynthesis. maybe you know that the plant is collecting sunlight and using this energy from the sun by chemistry reaction to store carbon dioxide and the water, and to make carbon hydrates from the carbon dioxide and the water from the ground. And these carbohydrates, in general, we say sugar, it's building their bodies. So the plants are building themselves by locking sun energy in the chemistry reaction. Then we use this sugar or the bodies of the plants to burn them, which is the opposite reaction, and to release this energy which is stored inside their bodies. This is the cycle. It's starting from the trees and the plants. Then we mill them and sometimes compress them. Depends of the way that we will use this biomass. I will go more in details in the next slides. We burn this in our power plants, and we are releasing CO2. Then the plants take this CO2 and again produce their bodies, which we burn again. So it's absolutely circulation without any wastes, and just it's a way to capture the sunlight for 30 years and then to release it in the combustion chain for a very short amount of time, depends of our industrial needs. There is two additional circles. The first one is the water circle, because when we burn the plants, we are releasing water in the atmosphere, which is raining and come again to the plants to again use it to combine in their bodies, water with the CO2. And the other one is the ash cycle, because the carbon and the minerals from their bodies we are using to fertilize the soil and to give it again this carbon and minerals to the plants to combine them and to build themselves. So all of this in general, from the business and the industrial point of view, making the plants and the biomass the best battery in the world, because there is no limitations, depends on us, but we can grow more sustainable or faster growing plants. There is no waste. It's a lifetime guarantee, because you don't have something to break in this battery, and it's working far before we decided to use it in our industry. So it's a tested process. We are just using it. We don't. It's not our production in general. So the different types of biomass. Here it's very interesting that I want to focus on you is the municipal solid waste. It's again a biomass, mainly biomass and some technical materials. And this is one of the problems in Bulgaria that I will go deeper in the next slides, because some people in the country are trying to present on the paper the waste like a biomass, and as in the previous lecture, we find a lot of forbidden materials in the biomass that should not be burnt, especially near to the cities. Industrial residues, it's again a big part of biomass, so it can be used. Sewage, by the way, it's very interesting that we are biomass reactors too. We are eating some plants and some animals, which is stored sunlight. We are using part of this sunlight, but we are very efficient in the usage, but we don't use all of the sunlight. So we are releasing in the sewage system a lot of the, a very big part of the energy, which can be used for producing another energy, more energy than we can collect from the food that we're eating. Of course, forest and agricultural crops. Animal residue, it's again big part now, especially in Bulgaria. We're starting to build these big bioreactors where the animal residues are converting to biogas, which biogas is collecting, which is very important because there is a lot of methane, which is even worse greenhouse gas than the carbon dioxide. And it's burning in the CHPs, in the cogenerations, which half of the energy from the cogeneration is electrical. Cogenerator, it's a motor like a car motor, but it's not rotating the wheels, it's rotating a generator of electricity. And with the wasted heat, they're feeding with heat the process of bioreacting, and sometimes even are heating some building near to these systems, etc., because there is a lot of heat that it's going out from this process. So not only the wood and the plants are the biomass that we can use, there is a lot of other biomass that most of the people don't see on the first view. When you go back to the forests and agriculturals, here it's very important to understand why there are so many types of biomass as a fuel. Mainly because of two reasons. The first one is transportation. The compression of the biomass is very expensive. The pellets are the most expensive biomass on the market because, first of all, we compress this biomass to receive maximum energy in smaller amount to transfer to big distances. For example, you cannot transport straw from United States to United Kingdom because the price of the transport will kill the business plan. That's why they're transporting pellets. Most of the biomass, because of that, it's using near on the field that it's produced because of the transportation and the cost of compressing this biomass. Especially the straw, it's you should use right on the place or to compress to pellets. The wood chips, according to our last calculations, if you should transport it on more than 100 kilometers from the place that you're producing the wood chips, it's not profitable. So it's killing your business plan. And the pellets are the best for transport, and not only that, the other reason, I said two reasons. First of all is transportation, second it's automatization. For example, if you should build automated line for feeding the reactor or feeding the combustion chamber with straw, it will be very, very hard. You need a lot of space, you need very big installations, very big machines. I prefer, from the business point of view, the wood chips even more than the pellets, because especially for places that you have wood, if you don't have, you must transport it, so again you are going to the pellets. But the wood chips, you can automate it because feeding is very simple of the reactor. 100 kilometers are quite enough for not so big installations for every city. For 100 kilometers here around, you can collect enough wood chips to feed the needs of the city, for example. You don't have this pressing needs, which need more energy and electricity and machines, etc. So the best fuel, from my point of view, when you have wood around you, it's to produce wood chips than the pellets. Pellets are better in the areas where you don't have a central heating installations, and the population is using biomass for heating their homes, because especially in the areas where the homes are built on top of a stone, when you cannot excavate the ground to make some service rooms of your building, or you don't have a lot of area to make some service buildings and rooms, you must burn this in your home, mainly in your living room. So when you go to the point that you must burn biomass in your living room, you cannot use something else than pellets, because they are quite clean, with small bags. You can buy from the market, put in your car, go in your living room, and put in the next to the fireplace. It's absolutely clean, it's absolutely automated, it's absolutely standardized, except some some examples that we saw. And because it's very compressed, the machine which is burning the pellets have not so much ash, so it's very easy to clean. And that's why in Italy, in Greece, because it's a lot of stone soil under the houses, you cannot excavate to make some place for your boiler or some combustion reactor. You're using in your living room, and that's why they're using a lot of pellets. But for a city like the city that I'm coming from, Varna in Bulgaria, we have a central district heating company, which is heating by hot water all of the houses in the city. And in the power plant, it's not necessary to use pellets, because they're couple of times, 3-4 times more expensive if we compare the same amount of wood, which means the same amount of energy. For example, 1 ton of wood, if we compare the wood chips, 1 ton of wood, and the pellets, again 1 ton of wood, of course the pellets will be more compressed and more standardized, but it will be 3-4 times more expensive in the pellet way. So if you have the possibility to have bigger installation, or even in your home, if you have some service room that you can install the boiler on wood chips, it will be very cheap to do it, to use the wood chips than the pellets. So when we speak about biomass, first we should speak where it's coming from, and then how to compress and standardize to use it in the automated reaction. So that's why there are so many different types of pellets, types of biomass. Agriculture, it's again agricultural biomass. It's again biomass that it's using a lot for pellets, but when you go out of the standardized wood pellet and start to put a lot of things inside, straw or some fruit pits, it's possible, other materials, the boilers which are using this kind of pellets are starting to make a lot of problems. The pellets are very standardized, but the boilers for pellets are standardized too. So if you start to mix the pellets or to go a bit out of the quality, you start to have a lot of problems, broken boilers, they start to work properly, or they start to produce a lot of ash, or they start to have some places that the ash it's blocking the boiler and stop the reaction inside. So it's a bit, if you don't have the control of the quality of the pellets, it's very hard to find a boiler that can use all type of pellets. There is no this kind of boiler. With the wood chips, it's not like that. The wood chips, you can mess with the fruit pits, you can mess with some straw, you can mess with some leaves from the field. If the season giving you free biomass, you can put a lot of things inside because of the simple construction of the feeding system to the boiler. Mainly it's just one hand which is doing like this and putting some biomass inside of the boiler. There is not a system for small doses of pellets. It's a big amount who is putting inside, and when it's burning, it's putting another amount. So it's very simple construction and giving you possibilities to make a lot of mixes and not so many problems in the combustion reaction. Just to give you an example why they are so different and why some people are preferring wood chips than wood pellets, but other people are preferring wood pellets because of their advantages. So this is maybe the most complicated way of using the biomass when we are using waste biomass from the waste. You can see here down that the waste first should be separated on biomass and some materials that can be recycled. So we first separating the recycled materials, and then the other biomass we start to feed the reactor with it. Here it's very important to know that there is a long process of burning. The burning, it's separated on stages. The wood, it's burning not only the wood, but the gases that wood is releasing during the burning. There is the whole different process, which name is pyrolysis, that you burn only the gas. You are heating the wood. This heat is gasificated the wood, and you are burning these gases. Even the gases you can separate on lighter and heavier gases. There are some oils that you can separate in the burning process, and if you want to burn in the maximum efficiency, you can burn separately each of these gases, the oils separately, and then the rest of the wood. So here, when we start to burn the wood, there is some pieces of wood and some gases that still are burning on this stage, and on this, and on this, and there is a ash that is coming from every process, and the reactors here are different. They have different design, especially for the gas that are burning in every stage, and different settings to have absolutely maximum burning and not wasting any piece of the energy which is collected in the food. In the end, there is some cleaning process, and all of the ash is going on the field to feed the photosynthesis on the field and to start the process again. All of the heat from the reactor is using first to produce steam, which is generating electricity, and the rest to heat some houses. This is the cogeneration in general. From here, the process is absolutely the same with the nuclear power plant. The difference is that not the nuclear reaction, but the biomass reaction, it's feeding the process with the heat. And the technology here is absolutely the same like the old steam locomotive there is nothing new in the whole process from hundreds of years. Only here we precise the burning of the biomass and start to take biomass from more places, but nothing new in the field of the industry. This is one good example. It's in Hungary, in the city of Pécs. 2007, the company that I worked for, that I used to work in, Veolia, buy this power plant. It's 50 megawatt electrical capacity wood chips burning boiler. It's one of the biggest in Europe. It's quite big for a pilot, but it's a pilot. Yeah, it's a pilot power plant. They test a lot of technologies inside. The interesting here is that this power plant, it's burning biomass from 130 kilometers around the power plant, which include 3 countries. And they have negotiations with all of the agricultural producers in these 3 countries for the next years in advance to bring all of the biomass that it's on the field. It doesn't matter what you're growing, it's a corn or it's some other grain or some fruits, all of the waste biomass from all of the area. It's Hungary, Serbia, and Croatia that are bringing all of the biomass to this power plant. So the biomass energy production in Bulgaria, it's the next section. First, where is Bulgaria? 1,500 kilometers from here. I just drove it yesterday with a car, so it seems that it's near, but it's not so much. It's a very green country, as you see on the map. 60% of the land is agricultural and 30% is covered by forests. And on this table you can see the potential of using of biomass. So the wood we are using, almost half of the wood which is possible, but unfortunately in the domestic installations, I will show later in the presentation that this is a very big problem because the domestic installations, they don't have this precise combustion reaction inside. But this later, when you see the table in yellow, you can see that the potential, it's almost half of it for wood. Waste from industry sector, it's 30%, but for agricultural, landfill gases and oils and wasted fats, we almost are not using, which is very, very big problem. One of the problems is that we have very big nuclear power plant, even, and when we was integrated in the European Union, we closed 3 from 5 of the reactors, and still we have a lot of energy. And even now we are exporting 10 to 20% of the produced electricity in the country to our neighbor countries. And we have coal mines, not so much like here. The coals are not so high quality, but still we are generating electricity from them. So in general, we have 76% of unused potential for the biomass. And now the country is trying to start the process but you will see in the next slides, of course, not in the best way. Energy consumption by sources in Bulgaria, you can see on top of all there is other renewables, and somewhere inside there is the biomass in Bulgaria. So still oil, coal, gas and nuclear are dominating. We have quite good hydropower potential in the country, but the renewables are just one very tiny line. On this graph you can see in green that other renewables in the last year are starting to move, but still less than 5% of the production in the country. Mainly these are bioreactors from animal manure and some industrial installations that start to add biomass to their combustion reactors, but not in general fuel switch, just they are adding additionally to their reactors, mainly to save some money because of the CO emissions. Because the CO emissions from the biomass, which is produced around the factories and power plants, are green according to the European standards, and you don't need to pay taxes. You don't need to buy a certificate to cover additional production from fossil fuels. Year-to-year change, you can see that other renewables is less than 0.5 terawatt hours, so still we are just starting to work in this sector on the country point of view. And the planned biomass energy production in Bulgaria, it's quite high. Our ministry planned to increase 5 times the energy production from biomass in the next 5 years. There are a lot of projects in development. That's why they decided that we can achieve this target, but still I believe that it's quite too high, because to start one project and to finish it's very different thing. We have National Forest Biomass Energy Action Plan from 2018 to 2027 with 6 priorities inside: sustainable production of biomass as a source of energy, efficient production of energy from biomass, because this is very big problem with the efficiency, decarbonization of the building stock, which contains inside 2 measures: switch from individual to group heating systems, because I will show in the next slides that this is a very big problem with the individual heating systems, and switch from fossil fuels to renewables. And the other 3 priorities are information, marketing, training, increasing public knowledge, because the people in Bulgaria, they, in their way of thinking, biomass is only wood, firing wood in the fireplace, and that's it. Mainly the industry is starting to think about the biomass, forced by the high prices of the CO emission certificates, which means that the European mechanism is working for the industry. The other problem is that the industry should have a proper environment to fuel switch fast enough before bankruptcy. So when you're forced, you should have environment to react. So the risk in the biomass energy production, first of them, these are risks from the practice, mixing the biomass with waste. we have a lot of problems in Bulgaria because Bulgaria is on the Black Sea, so we have very cheap ship transport from big part of the European countries. And as you see, in the last years, we have very big increasing of the waste, municipal waste from Italy, for example, from the European countries, but mainly from Italy. It's a well-known fact that in Italy, some special areas are collecting the waste from the municipalities, and they're searching on which cheaper place to send this waste than to manage in Italy, because the standards are very high and it's very expensive to manage in Italy. And they found Bulgaria as one of these places. Here I will show you two examples of two very big thermal power plants which already were catch how they are burning Italian wastes under a contract that they are burning a biomass. So even the Greenpeace Bulgaria revealed the correspondence between the Ministry of Environment and Water and the management of one of the power plants for experimental burning of 500,000 tons of waste, which is, by the way, they burned 80,000, but still 80,000 is the amount of waste that the second biggest Bulgarian city is burning. It's producing for 6 months, so for half of a year. Can you imagine about the 500,000? This is more than the produced waste in the country in general. Meanwhile, the other company, because in Bulgaria we have 14 district heating companies and 12 of them are owned by one person. And here in this presentation you see the stories of 3 of them. So it's a big business. Meanwhile, the district heating power plant in Sliven, another city, received a non-experimental but a regular permission to burn waste with the biomass that they are burning. So sometimes if the municipality or the government are giving the possibility, they're declaring that they are burning waste. But sometimes under the permission to burn biomass, they're burning waste, and not just the pieces in the pellets, but full bags and ships of waste. The other case is Brickell. They should burn straw. Even the last affair is that the Supreme Administrative Court accept that the pollution is not the key for the society, but the thermal power plant must work now because we need so much to be free of the Russian gas, even that the power plants produce less than 1% of the electricity in the country. So it's a bit a Pandora case. You are trying to be a green and to go from coils, because these are ex-coal power plants, from coal to biomass, but this is opening a lot of possibilities to some areas and some companies to make very bad for the environmental and social environments in the country. Deforestation and direct burning is the other risk. I will go back to this diagram, and to focus on this here, it's very, very important, because you know that sometimes the market is going too far in some direction. When the prices are good, the companies are starting to cut trees just to feed the power plants, which is not sustainable from the society point of view. It's it's better for the environment and for the society to first use this wood to produce some furniture, some goods, something to use, and then when their lifetime is on the end, to mill them and to generate the biomass for the power plant, but not to burn fresh wood in the power plant. This is wasting of material and wasting of possibilities. But it's quite often on the market because of the prices. When the prices go high, it's very profitable, and then the institutions should a bit regulate the market, a bit help to the market to go in the more sustainable way. In efficient combustion, here I will focus on another place on the graphic. So the domestic boilers and heaters on the biomass are very inefficient, and especially when we go back and speak about this pyrolysis, when you just burn the wood in the domestic environment, you cannot burn the full amount of the wood. You always release gases and smoke and ash and some small particles in the air, which is very, very big problem for the environment, for the health. And on top of that, you cannot utilize all of the energy which is in the biomass. That's why when we make last calculations and some tests, we understood that 70% of the heat is going through the chimney and it's not staying in the house. That's why it's better to use power plants, and that's why the biomass, it's better to be used in the cities where you have power plant with a very efficient combustion chamber, with very efficient cleaning installation, with filters, with very precise and efficient process of utilizing all of the heat and utilizes on the chimneys. On the power plant in Varna, the gases which are going outside of the power plant are on the 40 degrees. So you can imagine all of the temperature from the burning, it's collected till the end, and you're releasing a gas on the 40 degrees. From thousands of degrees to 40, everything is collected and sent it to the heaters in the homes. When you burn wood in your home, you cannot utilize, or it will be very, very expensive to build utilizer for the heat in every home. So that's why the most sustainable way is to burn the biomass in the power plant, not in the home. And that's why moving from pellets to wood chips, it's more efficient and more profitable when you go to the power plant. Free market effect. Yeah. I should finish. I have 2-3 slides maximum. Continue. What I saw in Hungary, they develop a very, very good system of biomass in the country, which increased the demand for biomass, which increased the prices. When I were 2070 or 80 in Hungary, they have higher price of the energy from biomass than the gas, which is absolutely incredible. It was very interesting for me, and this blocks the development of the sector because biomass, it's very hard to store, to take care about it, because there is some reactions that it should be dried, it should be transported, it should be stored on big areas, etc. The gas is very expensive. It's very cheap to work with. The installations, the boilers are very cheap, etc. And when the biomass price is going on the same level like the gas, the industry which is trying to burn biomass, it's blocked. Everybody start to move back to the gas, and it's impossible to force this process only with CO emission certificate prices. That's why the industry should be developed with the development of the biomass management and production, because when you put a lot of European money on the market, they have the money for the capital, they are buying and developing very fast the power plants, but you don't have the forest management and the biomass transportation and management to feed these power plants. And in one day you are waking up, you have a lot of power plants, but they are competing each other and they are blocking their work, and this is blocking the whole market. So my recommendation is increase the sustainability of biomass used through certification, preservation of the forests, and in general smart forest management, because we should start from the beginning. If you don't manage your forests, you cannot have enough biomass to develop the process after it. Switching from individual to cooperative heating, decentralized installations, something in between, not each house individual, not very big power plants, because this is the biggest power plant in patch that you don't have, most of the time you don't have enough biomass to feed the power plant. So not so big, but not so small to be inefficient, something in between, cooperative, but not a central power plant. Decentralization, something in between, is the best way. Building the ESCO mechanisms. These are mechanisms for financing of fuel switch installations, where there is a fund which is finance your project, but it's financing based on a guarantee of the result, which means that you can go more risky in your business because they're guarantee the results they're with you in the whole process, and in the end, if the result is a bit different, the fund is covering the investment, which forced the entrepreneurs to go in this sector. Now in Bulgaria, we start to develop some project based on ESCO mechanisms. And last but not least, strict control by the authorities in order to prevent the risks of inefficient or illegal biomass management in the country. So the last slide, I will share with you one of my favorite sentences. Nature is not inherited from our ancestors, but borrowed from our children. Thank you for your attention.
Thank you so much, Lyubomir. Okay, I think we have time. Any question, maybe, to Lyubomir, to Agnieszka? We have any question? Yes?
I would like to ask if Bulgaria is in European Green Deal.
Yeah?
Because the growth of biomass and switching to renewable sources in Bulgaria and policies, or it's different thing? Because I didn't quite understand why only woody biomass is considered as biomass and municipal waste and others are not. So,
In Bulgaria?
yes.
The biggest problem of Bulgaria is the socialism that finished 30 years ago, and a big part of the installations and the municipal waste management and all of these sectors are they were government property and management, and now they are in the hands of the people that are trying to make this kind of business with them. So there are some places that they try to use municipal waste. For example, in Varna, there is a good waste separation plant. They are separate its RDF, the fuel that you are producing when you separate the biomass that you are separating from the waste, and they are burning it in the cement factory near to the city. So there are some spots in the country that they start to try to test some installations, but the biggest installations are in the hand of the people who are trying to make some schemes and not to do something sustainable. They are trying to make money in the fastest possible way. Even Veolia, by the way, because the company is based on the 3 pillars: cleaning of water and water management, collecting and separating waste, and producing of heat. So it's a perfect circle economy. Veolia tried to buy some waste treatment plants in Bulgaria, but the level of management and way of doing of this business, it's moving to the European way, but still it's not quite clear to be possible even to be bought from this type of company and to manage it in the European way. So the transition is still, we are still making a transition to the European way of thinking, but it's hard to do that. Still, these are companies that are owned by somebody, and it's not just like this because the society wants just to switch. And the investments in the sector are hard to do because our country is still trying to collect all of the European money. We are late always with the standards. Now we late 6 months to change some standards and to receive the portion of the European funds. 6 months delay. The money are there and they are waiting to be used, and we are 6 months of delay to use the money that are prepared for you. Can you imagine? But we have very, very big possibilities, especially in the agricultural. I know about 2 very, very big projects. One is for the biggest fertilizer producer in the country. It's a foreign company, and now they are switching from gas to straw burning installation. Very big, tens of megawatts. Because we have very big agricultural land near to Varna, and we have a European regulation that you cannot leave the straw on the field. You should cut it. When you put a cutter on the harvester, this cutter is consuming a lot of the diesel fuel and start to be very expensive. And the agricultural producers says, look, you built your installation. Look, you built your installation. We will bring the straw to you, just not to cut it because it's so expensive. So there is some movement, but till now these are the numbers.
Can I have another one?
Yeah.
Okay.
Because you said about straw, and I read articles about amount of chlorine in straw,
Yeah.
and it causes corrosion of
The reactor, the boiler.
So if you put on different kinds of things, for example, mixing with pellets and other sources, we actually don't know if the boilers the fuel will cause a corrosion or not. So is it a way to obtain the amount of chlorine of the typical kind of straws mixed with other ones, or we are just putting in there and burning it at, we don't know actually how much chlorine it is, and will it cause a corrosion of boilers or not?
First, thank you for the question. First of all, yeah, this is a very big problem with straw. But first of all, the decision what the agricultural producers will produce, it's not manageable, or it's very hard to manage because they're looking the market prices and decide what to produce based on the market prices, not based on the reactor or the boiler that you just bought. So that's why it's very hard for the energy producers from agricultural biomass, because you should have in mind that your boiler should fit to everything that it's on the field, because even in the agricultural producement you should change what you're producing because of the soil. The soil needs to have a change of the production. So that's why everybody are trying to buy the most how to say, the reactor that can use every kind of biomass. But from the other way, this problem with the chlorium in the straw, it's a problem when you try to produce electricity. This is one of the things that I forgot to mention in the presentation. It's very different when you try to produce electricity from biomass and when you try to produce heat. The heat is very easy to produce. Even the straw, there is a reactor. Yes, the metal that you are building the boiler or the reactor from it's a bit more expensive, but the fuel, the straw, is less expensive, so it compensates and it's not a big problem. The problem is when you start to make a pyrolysis and to gasificate the straw, then this is a very, very big problem. And that's why when I work in Veolia, we go all over the world to investigate about a reactor for electricity production on straw. We found 5 projects which were very, very near to produce this kind of reactor, but we didn't find already finished working process. So yeah, it's a very big problem, especially when you try to produce electricity, because in the electricity you try to gasificate the straw with the pyrolysis. If you just burn it, it's not a big problem. So the mixing, it will increase the life of your boiler, but will not. It's not a solution. And again, with the mixing, you should have a sure fuel supply of something else, which you cannot rely, because the next year the biomass producer maybe will switch to something else, and you cannot be sure how much chlorium you will have this year in the straw and the next year, because it's moving again, depends on the climate and other things. That's why everybody are preferring more strong boilers with a wide range of biomass that can be used. But this is the situation at the moment. We hope that soon they will find a boiler or reactor to burn straw, because straw is everywhere. Every agricultural country have a lot of straw. With the straw, by the way, we are going in the next problem with the transportation of this. In Hungary, when I investigated the market, I saw a big company who just start to produce a machine for producing pellets from straw on the field. You're plugging to the tractor, and you're starting to produce from the straw on the field, and then to transport. Because even if you transport the straw to the some place that you produce the pellets, even then you don't have a very good profitability, especially now with this price of the diesel. It's crazy. So there are a lot of problems with the straw. as usual, the most cheaper fuel have the maximum problems. But this is the entrepreneurial environment to find a way to deal with that.
Thank you. Thank you.
Thank you. Yeah? Yes?
You said that the price of the food pellets are 3-4 times higher than wood chips.
Yes.
And I'm wondering what is the source of this difference in price? Because probably, well, of course, understand that we need this compression, and probably that involves a lot of energy.
Mm-hmm.
But is there any other factor that actually can reduce and maybe even make this process much more efficient? And another question, just related maybe to this first one, do we need any other ingredients, additives other than biomass? So basically, are we only using compression to make these pellets, or are we need any kind of resins or any kind of other natural ingredients, let's say?
In the pellets, maybe you should. Maybe you should add something to what I will say. But in the pellets, this is the problem that the best pellet, it's you should not add anything to that, and not only you should use only the core of the wood. Everything else, it's a problem, and it's damaging the process. And not only yes, but it's not only homogeneous, but clean wood is the best for the pellets, and even what kind of wood? Because
The natural lignin is gonna act as a binder.
Oh, okay.
yes.
With other types or mixed ones, we need to have additives and binders.
And when you buy a very good boiler based on pellets, and when you start to adding some pellets that they didn't clean the wood or mix some woods, you start to have problems with the reaction. Or you don't have a perfect burning, or even the boiler is stopping to work, which is very big problem. Especially in the industrial installation, especially when it's automated and there is no person on the field to clean, to restart the process. You saw what with the automatization. So you can imagine in one power plant. And this is why when you have 2 power plants, both of them are working with biomass, but one of them is working with pellets, another one is with wood chips. And if you produce 2 absolute equal amounts of biomass, of wood biomass, for this here, you should clean the biomass. You should, and even part of the biomass will move from here to here, because this reactor can work with the wasted material from the first. Even here you can add some fruit pits or something from the producement of alcohol, some waste, some municipal waste. In some portion, it's okay to go inside. Here you should clean, you should dry, you should be careful what kind of food, and then you should mill. You should, this milling process is again, it's making more expensive the pellet, because here you are milling but on very big pieces. Here you should mill very precise, and then you should dry it again. You should compress it. This compressment of food, it's I saw an entrepreneur that he bought a factory for producing of macaroni. And switch it to producement of wood pellets. By the way, the process is absolutely the same.
The pressures probably are not so high.
Yeah, depends, but the problem is with this matrix in the end, with the holes that the material should cross it and to fit the pellets. This end part of the machine, when they used the macaroni type of it, they must change it every week. They throw away and buy a new one. So I saw everything that you can imagine, every kind of tests and pilots, but it's working. But there, for example, the problem was that they trying to dry the wood with the burning gases from the wood, some circulation. But even when you dry the wood with the smoke of burning wood, you're decreasing the quality of the pellets. So you should burn the wood, but then to heat the water, and the water to dry the pellet material, which generate a lot of wasted heat. So it's very precise process. Maybe this is the problem, and this is the biggest advantage and the biggest problem. It's precise process. So if you work in Japanese, where everything is precise, it's good because you have strict producement of pellets, you have strict power plants, strict process. The full process is strict, but here in our areas, Bulgaria, Poland, not so much. You need installation that can keep working even if somebody plays some games on the yes, on the whole process. So this is because I'm speaking from the entrepreneurial point of view, because when you invest a lot of money in something, you don't have the possibility to rely on all of the chain of the suppliers, of the material, of the equipment, of everything. You should have some reserves. You need to have some reserves. Because if you build some Japanese installation in Bulgaria, you should bring pellets from Japan.
Yeah.
Yeah.
Maybe in the future.
Yes, yes.
Okay. We have any question? I don't see. Yes? Okay.
I have
Please.
a question to you because which type of trees are usually considered as more of coniferous trees or deciduous trees?
That depends what you're going to use the pellets for. So when it comes to heating, you have both type of trees. However, when it comes to grilling, the coniferous trees are not good for that because the resins can generate gases that obviously interfere with your food. But at this point, you have variety of the materials on the market. We actually tested quite a few different types, both here in Europe, and I shipped some stuff from US here. Especially the grilling producers create insane type of product, and it's not just apple, apricot, or cherry. But recently we found on the market that they already mix the wood with spices. So there are wood pellets mixed with paprika or basil. We haven't tested that yet. But yeah, you have a lot of variety on the market. Thank you. Actually, I have a quick question.
Yeah.
Because I was intrigued by one of your slides. Back at the beginning, you show energy consumption in Bulgaria.
Mm-hmm.
And for some reason, around 1990, energy consumption.
Yeah.
This one, energy consumption starts going down. How is this possible when typically we saw energy demand rising?
So this is when we go out of the socialism and we go on the free market, and the market shows us that the goods that we are producing are not enough efficient to go on the market. First. Second, there is a big process of privatization of the factories, which many of them go into bankruptcy. Other of them was privatized just to steal them. And even this that the entrepreneurs educated in the socialistic environments try to manage, they produced goods which are not profitable, which are not competitive to the market, etc. So this is the energy crash. It's an economic tool. When you see the finance graph, it's absolutely the same. that's why we start a project for a second nuclear power plant, which we didn't finish. Even now there are some discussions about it. But we have 5 reactors, we cut 3 of them, we have 2 now, and we still have a lot of work on the energy efficiency, because it's smarter to increase the energy efficiency than to invest in more installations to feed these inefficient buildings or industry, or it doesn't matter what. So this is the situation, and as you see after it, there is some process of efficiency. Here, the decreasing, it's a question of efficiency, not that the economy go down. Even now, the economy of the country is going a bit up.
Okay, maybe. Bravo. Bravo. Thank you very much for your participation in the meeting, in the open dual lecture, and I'm really thankful that so many of you have found on the time to be here. Only several people, but very interesting question to Agnieszka and Lyubomir. Thank you very much. Okay, close of the meeting now. See you later. See you maybe next time.